Hey everyone, welcome to the Genie Life Sciences demo room. I'm Nick Ritzo. I'm our lead in-house applications engineer here. And today I'm going to be kicking off a series that for now will be called Genie Tips and Tricks. But if you have any other names, more whimsical, maybe even involving some sort of, magic element given us as Genie, drop them in the comments. Let me know. Definitely not setting the bar too high so far on how clever we're being. So, anyways, what I'm going to be doing here today is walking through kind of the products that we offer and how we're using them to address current needs in the market, focusing mainly around end-to-end applications and alleviating bottlenecks in automation that can exist throughout your lab space. So what I'm going to do here today is basically start with our Genie LabMate here, which is going to be controlled by our Genie LabOS cloud-based orchestration software. And I'm going to start with kind of a very simple explanation and showing of the features for how you'll be able to provide solutions for basic applications such as PCR setup, things of that nature. And then I'm going to kind of move forward in kind of complexity and kind of abstraction from just using the LabMate to more moving towards using on-deck devices, as you can see here, then moving towards LabMate-centered work cells, which is going to be composed of everything that's currently sitting behind the LabMate. And afterwards, we can continue that abstraction with showing some of the other devices that Genie LabOS is able to control and showing some of the kind of expert features that allow you to code how you're going to control these outside of kind of our normal, very easy to use UI interface. So what I'm going to do first here is I'm going to pop up our software and just show you kind of what it looks like to be able to perform simple applications on the Genie LabMate. The first thing that I'm going to do here is I'm going to drag and drop in this transfer step. This also exists under all of our liquid handling commands here. Once we've dragged that in, we are going to have to specify our source destination labwares, as well as what liquid and volumes we're going to be moving. To do that, we can pop into the labware section here. If you have starred or favorited labware, it will populate into this first section. So I can say that I'm going to be moving some sort of liquid from a trough, and we're going to be going into a Biorad PCR plate. We can also say that we're going to be moving from tubes in the following transfer step. Into that same Biorad PCR plate. If I click back into seeing the ones that are currently in my labware, I can add liquid into this. Say I'm going to add a master mix, quite a bit of master mix in a large trough. Say we're starting with 50 milliliters. You can also always assign colors to these liquids. You can create your own liquids. All of the liquids are going to be tied to liquid classes, which you will see in a moment, which are going to lead towards the default best practices, as we have set here at Genie. And into these tubes, we can say that we have 8 samples. At 1 mil each. As you can see here, they have populated in as different colors. And now we have to specify where these liquids are going to be moved to in our final plate. So we have our selection of source. Now we can say our selection of destination, as well as what the transfer volume is going to be here. Say that we're moving 100 microliters into that. And we will do the similar action with our source DNA. And say we're going to add 50 microliters in here. And that is all that you are going to be required to do at these setup steps for specifying how your liquid is going to be moving. The next step is kind of unique to Genie. As you can tell here, we are not actually specifying any of the, pipettes or any of the kind of, higher level pipetting behaviors that you would typically do. Instead, we have the ability to fit this to instrumentation once we give it a name. And we have the ability to select various liquid handlers that we control. I'll go more into this once we move towards kind of an abstracted view of how we control work cells. But for now, we can say that we're going to create our instrument settings against the GLS1 LabMate. It's going to go through and simulate to make sure there are no syntax errors. Say you're trying to overfill a well, or you're trying to pull more liquid than is available. It will give you an error there. Now that we've fit to this instrument, we have auto-generated tips based on your specified movements. As you can see here, one of the transfers was for 100 microliters, so we've defaulted to using 200 microliter tips, whereas the other transfer was 50 microliters, so we're using a smaller tip size for best practices to be able to be used there. And that's kind of the basis of how you're going to set up a really simple liquid transfer. These values that are going to be kind of located in these higher level pipetting behaviors are going to be defaulted best practices based on the liquids and the liquid class that's associated with them. So now quickly to pop back into a view of the LabMate itself, we can go through a few of the features that are going to be able to allow you to perform this assay with a degree of reproducibility that is not going to be possible with other liquid handlers. The first thing that I'll show here as we open up these enclosures is that we have an 8-channel spanning pipette head. It has the ability to perform individual Z movements and therefore has the ability to perform LLD with any one of these tips based on pressure. With that, you have the ability to detect liquids that are going to be very difficult to detect with capacitance-based liquid level detection. And you also have the ability with this head to very easily remove it with this golden latch up here. And this can be done anytime, even at runtime, so that the instrument is going to have as little downtime as possible. With the modularity of this system, you will remove current bottlenecks in the lab ecosystem, as the need for an engineer to come on site and troubleshoot and diagnose is going to be greatly alleviated by the ability to swap out your main pipetting component of the head. The seals on the head are a novel design allowing for tip pickups across a wide variety of tips. So you have the ability to source several tip types from us and be guaranteed to always have a supply chain of those. To move forward further, as these doors close on me, we can also address these on-deck devices that you see on the side here. In order to do that, we're going to kind of move forward in a degree of complexity from the basic application that you have just seen to a more well-rounded and more complicated setup. So say now that I want to come back to my basic PCR setup, and I want to automate this further. So now I'm going to want to shake this plate after it has been added to by our reagents and our samples. To do that, I'm going to pull in a time shake command. I'm going to specify which plate I'm going to want to be shaking. And I'm also going to specify here what parameters I'm going to want to shake it at. So if I have 1 minute at 1500 RPMs, I can save this as well. I can fit to an instrument again. I can name this PCR setup with shake. And I can specify which shaker I want to now use. So you can see that we've integrated with several shakers here. I can say that I want to utilize the one that is currently on the deck. And this is also going to start to move into kind of our work cell configuration, as I can also specify if I want to move this manually, or do I want to have a work cell be able to move this plate to the shaker. In this example, what would be chosen here to have that function occur is going to be called the LabMate work cell. And if I step out of this quickly and go into our virtual lab space, you can see that we have quite a few instruments in our demo area. And once I move into the LabMate work cell, it's going to show to me all of the connected devices which are being controlled by Genie for this work cell. So you can see here, these are specified as the on-deck accessories for the LabMate, but I also have the ability to move that same plate that I was going to move to the shaker to any one of these other devices. Say that I want to do a dispensing step or a wash, or even a plate stamping step at 96 or 300 or 384 compatibility. So as you can see through here, we have a robotic arm that has the ability to move plates between all of these work cells. So this is, again, stepping up in complexity from the kind of basic LabMate. Now through the LabMate with on-deck accessories. And now we can abstract that even further and say that we are using the LabMate with an entire work cell here. I can show you quickly the movement of the arm as it comes in and grabs an IDOT plate from the deck and is going to move it over to the dispenser once we give it the time to initialize. And a quick note on this is that all of these devices are being controlled by Genie at a level. Oh, here we go with the arm picking up an IDOT plate, moving it over, as you can see in the back there, to the IDOT, and then returning to its home position. We could have it do the reverse if we wanted to bring that plate back. And just quickly, I'll go back to sharing my screen for the software to show what it looks like for the IDOT to integrate to a level where we can open and close this for kind of a diagnostic standpoint. But also we can come in here and we can say that I want to perform a dispenser step here. And again, it's going to be a simple drag and drop command. So you do not need to understand the IDOT's software to any degree to be able to integrate this into your work cell. Nor do you need to know how to teach the ARM standalone, as that will also be controlled through our software. So a lot of the bottlenecks that you would have faced earlier, such as having to teach your ARM through its own pendant, having to understand how the IDOT software works, are now alleviated through Genie LabOS. To abstract this idea further, if we went back to our PCR setup here, and I said that I want to take this same fit and I want to utilize a different instrument, I now have the ability to come in here and say that I want to perform a 96 stamping move. I have the ability to specify that I'm going to use a Perkin Elmer Revity Zephyr IQ, which we have located at the other side of this lab, which I will show in a moment. And it also contains an on-deck thermal cycler, as well as the ability to move it manually or to have it specified to be done by the work cell that's to my right. So I can create these instrument settings. And this is what we call your first authoring step here as instrument agnostic. So when you are writing out this PCR setup protocol, you are not specifying at any moment there the exact instrument that you are going to be using. So once you have it written out, you can push it to not only an entire fleet of LabMates, but you would also have the ability to push it to any other instrumentation that we have integrated with that will provide you with the ability to be as flexible and reproducible in your lab space as possible. So now that we've covered the idea of how the LabMate be a standalone solution for simpler applications, and then on top of that, have the ability to integrate with devices on deck to provide a more robust solution for your application needs. And further, as you move up in complexity and you are requiring to have other devices integrated into your workflow, all of those steps can be controlled through Genie LabOS. Now to step even further into the power of our cloud-based software, say that you have the need to create a workflow with instrumentation that does not currently exist within our space. You have the ability in the background to code your own Python plugins, which can then be utilized as drag and drop commands to be handed over to your end scientists. As an example of this, if I share my screen here, yet again, and I go into my virtual lab space, we have several custom created scripts that allow us to perform functions that would not have been possible in the simple LabOS schema of drag and drop commands. So again, you always have the ability to use the simple drag and drop commands, even with these more complicated plugins. But if you need to step further into the complex world of work cells, and you have the ability to code for yourself or you would like us to come in and code something for you, you now have the ability to perform basically any function that could be possible with your current automation. With this, it allows for a degree of modularity and flexibility in your current automation that would not be provided by any other liquid handler or automation control services. So now I went ahead and I ran what is called the Zephyr, because it utilizes the PerkinElmer Zephyr, and OpenTron's demo here. What you will be able to see is the ability for two liquid handlers, a 96 head plate stamper, and the OpenTron single channel pipette to be working in concert with each other through LabOS. So if I run this, and I can stop sharing my screen, and I'll change over the camera angle here to pan over to this other work cell. As we walk around it, you can see that we have the OpenTron's OT2, we have a PerkinElmer or Revity twister, and we have the 96 head Zephyr. So again, if this is going to be a command that you are going to run frequently, you can have this specified as a drag and drop so that your end user does not have to see any of the code that you've put together, and instead only has to run a singular command. And you still have the ability to leverage our run tracing, run accounts, user management, and easy to understand UI for all of the features that you have just provided a complex bit of code for. So now, once this has finished its pipetting behavior, it's going to go ahead and move the plate using its on-deck gripper to a location where the robotic arm has the ability to come over and select this plate and move it to the OpenTrons. The twister arm does take a second to initialize internally before moving over to be able to access this plate. And we'll then whip around and place the plate onto the deck space here. The OpenTrons will then begin to pipette. I will probably not show you the entirety of these pipetting motions once you have understood what the power is of Genie LabOS to control all of these features. There it goes. It is also using our current plate definitions for everything. So any plate that we've onboarded into the software, you would have the ability to reference automatically with these other pieces of automation. And that will conclude the brief overview of all of the capacity and the capabilities that Genie LabOS and the Genie LabMate in concert will be able to provide to your lab space. Again, with a key focus on trying to provide end-to-end application solutions, as well as the ability to automate specific bottlenecks in your laboratory that otherwise would have been incredibly costly or time-consuming to be able to alleviate. I hope you've enjoyed it. Definitely let us know if you've got any questions or if you'd like a demo of any of these features kind of in more depth. Otherwise, have a good day. We'll see you at the next one, hopefully with a more clever name for our tips and tricks. Thank you.